Am I audible?
Yes, sir.
Okay. So let us wait for 5 minutes more so that more participants can join the meeting. Then we will start. So let me start. Welcome you all to the third week tutorial of multivariable calculus. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am pursuing my PhD in the broad area of fractal geometry and dynamical systems. I am the tutorial assistant of this course. In this tutorial, we will do some illustration on the basis of the lectures that include the topic wait, that includes the topic change of variables, Euler's theorem for homogeneous function, and tangent plane and normal lines, and extreme values. Someone has comment something. Let me check first that. Yeah, in fact, you can observe in the assignments also. So they are quite similar. Rest you may refer to the lectures also. So let me start with the question number one. If fxy equal to x to the power 5 plus y to the power 5 divided by x square plus y square, then find the value of x fx plus y f. Please try this, then we will discuss.
So 3 into x to the power 5 plus y to the power 5 by x square plus y square.
So that means 3 into f, right?
Yes, sir. Euler's theorem.
Okay. But my question here is first that why we are applying uh, Guraman. Okay. So my question here is that why are you applying Euler's theorem? Like, how did you get that idea? It might be the possibility that you can partially differentiate f with respect to x or with respect to y. Why you are thinking about only Euler's theorem?
So firstly, this is a homogeneous function. We can
Okay,
check that.
so I think I have told you about the homogeneous function of degree n in the last lecture. Maybe.
Yes, sir. Yes, sir.
So what is the definition of homogeneous function with degree n?
Sir, the definition would be, I mean, if f is a
Yes.
function of n independent variables,
Okay.
then we say that f is homogeneous if
Mm-hmm.
f of lambda into x1 x2 xn is equals to lambda power n into f of x1 x2 xn. So
Okay.
that will be the homogeneous function of order
So,
n.
okay. I'm just recalling by just writing what is the exact definition of homogeneous function of degree n. I'm not writing formally. So, a function f of n variable is said to be homogeneous of degree n if f of, since we have used f above, so here I will use g to avoid the confusion. This will be lambda times lambda to the power n f x1 x2. Then we say that f is a homogeneous function of degree n. Okay. So for this question, there is one approach that we can partially differentiate f with respect to x and as well as with respect to y, and we can put the values in this equation. But it will be quite difficult. The reason is there is a factor in denominator, that is x square plus y square. So calculation will become more critical to do. So, and we can also observe here that this function is a homogeneous function of degree 3. How? Substitute by lambda x and y by lambda y, then we will get lambda to the power 5, x to the power 5, lambda to the power 5, y to the power 5, divide by lambda square x square plus lambda square y square. So this will come out to be lambda to the power 3 fxy. So what we can say, thus f is a homogeneous function of degree 3. Now in the week 3 lecture, there is a lecture based on Euler theorem, Euler theorem for homogeneous function. So let me first recall that Euler theorem formally. What is there?
So the Euler's theorem was something like if a function is
Yes,
homogeneous and uh, and their first and second order partial derivative exists and continuous,
yes.
then we can say that x f of x
Mm-hmm,
into y f of y is equal to n, which is the order of the homogeneous equation, into
mm-hmm,
the function. And the second one was x square uh, del square f by del x square plus
mm-hmm.
2xy
Yes,
del square f by del y del x plus
okay,
y square del square f by del y square
yes.
is equals to n into n minus 1
1, mm,
n into n minus 1 into
f.
f.
Okay, yeah, absolutely right. So let me write a formal definition for others also. If fxy is homogeneous function of degree n, in variable x and y and has continuous partial, in fact first and second partial, continuous first and second order partial derivative, then we can see that x times fx plus y times fy will be equal to n times f. This is our first result, and the second one is x square fxx 2xy fxy y square fyy is equal to n times n minus 1 times f. I hope this you were saying somebody. So in fact, you are looking this equation number one. One can observe that um, we can apply the Euler's theorem in this question if we can prove that this function is a homogeneous function of some degree n. Since we have proven that this is a function of homogeneous degree 3, therefore we can apply Euler's theorem here. So from the Euler's theorem, we can say that x times fx plus y times fy. Since degree is 3, so that means the value of n will be 3. So it will come out to be 3 times f. Okay. So let me mention this theorem with the different color so that it will reflect that it is different from this question. So I hope everybody understood this question. If anybody has any doubt, he or she can ask first. Otherwise, let us move to the next question. Okay, if not, then let me move to the next question. The second question is find out the Jacobian del uv divided by del xy where u is equal to e to the power x sin y and v is equal to x ln sin y. First find out this, then find del xy. Please try this. Till then, let me do some more changes here. Please try this. Jacobian. Jacobian, we have the sir has told in the lecture also in the lectures of change of variables. From that we know that the formula of the Jacobian. Excuse me. So what is the formula of Jacobian first of all? Del u v del xy. It is equal to the determinant of del u over del x del u over del y, del v over del x, del v over del y. Now we know that the value of u is e to the power x sine y and the value of v is x ln sine y. So we need to find out the partial derivative of u and v with respect to x and y. So first of all, let us find out the partial derivative of u with respect to x and as well as y. So del u over del x. Again, we will treat y as independent variable. Therefore, it will come out and we will differentiate only e to the power x, and which is come out to be again e to the power x sine y. Next one is v is equal to e to, we have to find out also del u over del y. Again, we will treat x as in independent. So, or sorry, so we will treat x as constant. So it will come out and will partially differentiate only. And in fact, we can say here we will differentiate only sine y. So it will be e to the power x cos y. Now the next function is v. What is v? V is x ln sine y. So we need to differentiate this v with respect to x. That means y will be treated as constant. So it will be ln sine y del over del x of x, which will come out to be ln sine y. While del v by del y will be x del over del y sine y. Now I am interested how to find out the derivative of this. Can anybody let me know how to find out the derivative? Because here there are two function composition of two function, that is logarithmic base e and the sine trigonometric function. So how one can find out this derivative?
It's a chain rule.
Chain rule. So we will uh, treat ln as one function, and we will consider this as some nex. So we will differentiate with respect to this. So it will come out to be 1 by sine y, and then we will differentiate that we have assumed sine y as some other function or other parameter. So it will come out to be x. I hope I am correct. So put these values in this equation 1 to get the Jacobian of this change of variables. So it will come out to be uv del xy. So what are the first two factors? E to the power x sine y and e to the power x cos sine y, e to the power x cos y. And the other one is ln sine y x cot y. So multiply it. It will give you x e to the power x cos y, if I'm not wrong. So it will be e to the power x cos y ln sin y. I hope, or you can more simplify it in the way cos y x minus ln sin y. I hope everybody got this answer only. If anybody has get a different answer, you can ask. So many, did you get the same answer?
Yes, sir, I've got the same answer.
Okay. So what about this Jacobian? Now, will we need to compute again del x by del u, that the we know the general formula is del x by del u, del x by del v, del y by del u, and del y by del v. And also we have to first represent this x and y in terms of u and v, because in the given question we have given u as a function of x and y and v as a function of x and y. So we need to first compute x as a function of u and v and y as a function of u and v. So do we need to do these much calculation?
No, sir. We
Why?
will just apply the properties of Jacobian that we know, and we will
So what
get
is that
the reciprocal
property?
of the previous one.
What is that property?
Sir, if del v by del x del y is
Hmm.
j, then and del xy by del uv is j dash, then we
Okay,
know that j into j dash is equals to 1.
good. So he's saying that Jacobian of this into Jacobian of xy, this is equal to 1. And we know that we have already calculated the Jacobian of del uv divided by del xy. So Jacobian of xy with respect to uv is nothing but 1 by Jacobian of this, which is e to the power x cos y x minus ln sin y, which we can more simplify in the way e to the power minus x secant function of y divided by x minus ln sin. I hope everybody is convinced with this explanation and this answer. Okay, then let me move to the third question. If the equation of the tangent plane to the surface 2x square plus 3y square minus z square equal to 5 at 3 minus 2, 5 is some alpha x plus beta y minus 5z is equal to 5. Then find the value of alpha plus beta and also find the equation of the normal line at 3 minus 2 and 5. So we need to find out the equation of a tangent plane. Then we can guess, we can find out what is alpha or beta. Then we can find out this alpha plus beta. And following that procedure, we also need to find out the equation of normal line. So let's try first. Try it yourself. Then I will let you know. Please try this question. So I'm just writing Just recalling actually the equation of the tangent plane to some f x y z equal to c at some point x naught y naught z naught is nothing but f x at x naught y naught z naught into x minus x naught plus f y at x naught y naught z naught into y minus y naught plus f z at x naught y naught z naught into z minus z naught to 0. So this is the equation of the tangent plane, while the equation, okay, I will write it further. So first of all, let us concentrate on this equation of tangent plane. Then we will discuss the equation of normal line. So I have changed the color just to note that this we are recalling from our lecture. So did anybody find out already that what is the equation of this tangent plane, or else I can say what is the value of this alpha plus beta? So
So the value of
yes, please.
0, 0, sir.
0. Okay. So for this, we need to compute this partial derivative of f at x. Oh, sorry, partial derivative of f with respect to x at the point x naught, y naught, z naught. Similarly, fy and fz. So first of all, let us compute what is. Let us think what is this fxyz. So fxyz is nothing but, from the question you can observe that fxyz is equal to this function, that is 2x square plus 3y square minus z. Okay. Now we need to find out its partial derivative with respect to x, y, and z. So it will come out to be 4 times x, and we will treat y and z as constant since we are doing partial derivative. Similarly, f with respect to y will come out to be 6y, and fz, it will be come out to be minus 2z. So we will put the point. What is the point? 3 minus 2 comma 5 in these values. So fx 3 minus 2 and 5. This will be 4 threes are 12. 3 minus 2 and 5. This will come out to be minus 12. And fz will come out to be 3 minus 2 and 5. Let me correct. It will be minus 10. So we will put, I'm sorry, we will put these values in this equation. You can say equation number star. So we will get 12 times x minus 3 minus 12 times y plus 2 minus 10 times z minus 5 equal to 0. So let us form this equation into the given this form. Then we will decide what is alpha, what is beta, and what is their addition. So it will give us 12x minus 12y minus 10z. It will come out to be 12 is a 36 minus 12 to the, or it will be plus 24. This will be minus minus plus, and this will be minus 50. So what will it give? It will give 12x minus 12y minus 10z will be equal to 10, I think. And this will again give 6x minus 6y minus 10z equal to 5. And we have given the equation of the form alpha x plus beta y minus 5z equal to 5. So this seems similar to that, or in fact same to that. So we can get alpha is equal to this 6, and since there is a plus beta, so it will be minus 6. So what is the addition of alpha plus beta? It will be 6 minus 6, which is equal to 0. Now, what is the another question? They are asking that find the equation of normal line of the same f at the point 3 minus 2 and 5. So let me first recall that what is the equation of normal line. So the equation of normal line to f x y z is equal to c at some point x naught, y naught, z naught is, what is that? X is equal to x naught plus f x x naught, y naught, z naught times t. Y is equal to y naught partial derivative with respect to y at the point t, and z is equal to z naught x naught, y naught, z naught t, where t is any real number. So we know that what is our x naught, y naught, z naught, and in fact we also know that these values, okay, these value is 12 minus 12 and minus 10. So we just need to put these values in this equation. So we will get our normal line equation as x is equal to, the first point is 3. So it will be 3, and what is the value of first point? 12. So it will be 3 plus 12t. The other one is minus 2. That y naught value is minus 2. And this is minus 12. So this will be come out to be minus 12t. Now z is equal to 5 minus 10t, because z naught is 5 and the partial derivative of f at with respect to z at the point, given point, is minus 10. Here t is any real number. So this is the equation of normal line. I hope Soumyadev you get the same equation of normal line.
Yes, sir.
I'm again asking you, or again saying you
Yes,
that
sir. Yes, sir. I've
okay,
got the same
no, no,
answer.
no. Soumyadev, I'm saying something else. Um, I'm again announcing, if anybody is feeling any doubt, then he or she can stop me and ask. So let me go to question number 4. Let the equation of the normal line to the surface x square plus 2 y square plus 3 z square is equal to 6 at 1 minus 2 comma 4 is x is equal to 1 plus p times t, y is equal to minus 2 minus q times t, and z is equal to minus r plus 24 times t, where this t is any real number. Then find the value of p plus q minus r and Also find the equation of the tangent plane at 1 minus 2, 4. So we have given the equation of normal line and we need to find out the value of p plus q minus r, and also again then after that we have to find out the equation of tangent plane. So again I'm giving you a some time to find out what will be the values.
1 minus 2 comma 4 does not lie on the given surface.
1 minus 2 and 4. 1, 8. Okay, understood. So let us think some other points which lie on this surface. So we can
Sir,
take
111 will
one,
be
one, one.
blind.
Yeah, yeah, 1, 1, 1. That's what I'm writing. So we can think of 1, 1, 1. So one may do have 1, comma 1, comma 1. Then this will be changed a little. This will be 1 minus qt. And I guess again this will also change with some factor. So we will see what would be that. So here let us compute these values first. So fxyz will be x square plus 2 y square plus 3 z square. So partial derivative of f with respect to x will be 2x. Partial derivative of x with respect to this is 4y, 6z. So it will give us 1, 1, 1, 2. It will be 4. It will be 6. So what is the equation of the tangent plane? It is the value of this first partial derivative with respect to x at this point is 2 times of x minus 1 plus 4 times of y minus 1 plus 6 times of z minus 1, 0. This is equation of a tangent plane I have find out first. So let me change here the point 1, 1, 1. So I will write it again. So we have to focus on normal line. So normal line is x minus 1 divided by what is that? 1 plus 2 times of t. Y is equal to 1 plus 4 times of t. Z is equal to 1 plus 6 times of t. Is these values are correct? Somebody you can cross verify.
Yes, sir.
Okay. So since we got here, it will be 6 and let me change here. So from here we can compare these two equations and we can get the value of P as 2 and the value of Q. In fact, minus Q will be equal to 4 since we have given the equation in that form, and the value of minus R is equal to 1. So Q will be minus 4 and R will be minus 1. So we need to find, we have asked to find out the value of P plus Q minus R. Yes,
Suppose if you take the proportionate values of 2, 4, 6.
yes,
If you take the proportionate values of 2, 4, 6 as 1, 2, 3,
okay.
what will be your equation, parametric form?
See, first of all, uh, we have here the point 1, 1 minus r. Okay, so we need to put it like that only, since we are finding out this with perspective of this question. And if you are changing that, you are proportionating the value of this 1, 2, and 3. So for that purpose, we need to change it like that. Suppose x minus 1, this is the equation of the normal line, z minus 1 is equal to 6. So it will, we can write it like that, 1 y minus 1 divided by 2, z minus 1 divided by 3. Take it as some lambda parameter. So it will come out to be 1 plus t, 1 plus, sorry, lambda, and y is equal to 1 plus 2 lambda, and z is equal to 1 plus 3 lambda. I hope this you were asking about. Uh, or you want to ask something else? Okay. So here the value of p plus q minus r, it will be 2 minus 4 minus of minus 1. So it will be 2 minus 4 and plus 1, which will come out to be minus 1. So this is the value of our asked p plus q minus r. And here one student has asked me that what if this proportionate 2, 4, 6 we will change at, or we will replace at 1, 2, 3. So we can do in the following way, that I have right here, this is a parameterized form. So in general, we know that this is the equation of normal line, that is, let me write it so that you can connect it. Sorry. So x minus x naught divided by fx at point p naught, y minus y naught, fy at point p naught, and z minus z naught and fz at p naught. Here p naught is equal to x naught, y naught, and z naught. So we can write in general form, that is x minus 1 divided by 2, y minus 1 divided by 4, and z minus 1 divided by 6. Since these three has a vector of 2, so we can divide, or you can say we can take common. We can cancel it out. It will become out to be 1, 2, 3, and we will again assume it equal to the some parameter lambda. Then we can find out this parameterized form. Now the next question in this, we have asked for the equation of the tangent plane. Since we know that the partial derivative 2, 4, 6 are these partial derivative at p naught, so it will be 2 times of x minus 1, 4 times of y minus 1, and 6 times of z minus 1 equal to 0. Now these all are the we can take factor of 2 is common, so it will be x minus 1, 2 times of y minus 1, 3 times of z minus 1, 0. It will be x plus 2y plus 3z, which will equal to 1 plus 2 plus 3. So x plus 2y plus 3z is equal to 6 is the equation of the tangent plane for fxyz c at 1, 1, 1. Or else precisely I can write here, this is the required. Okay, so let us move to the next question, that is question number 5.
Excuse me, what about the values of p plus q minus r? That value will
I
it not?
have I have already computed here.
You are computed with 2, 4, 6 as the direction ratios. If it
Yes.
is 2, 3, what about your PQR values? Will it be the
Okay.
same?
Yes. It will be the same.
How you compare these?
Uh, wait. There is a change. There is a change. Yes. I understood the question. There is a change. Here it is P, Q, and this is minus R. Okay. Minus R value will be the same, and the P and Q will be changed as 1 and minus 2. Okay. So it will be, I'm again computing that with respect to this direction ratio. So with respect to this direction ratio, I can say that P will be equal to 1, Q will be equal to minus 2, and R will be equal to minus 1. So it will be P plus Q minus R minus 2 plus 1. It will be come out to be 0. And this is changing because we have changed the direction ratio, and here in the given equation P and Q represents the direction ratio while the R represent this point. Okay.
You cannot have two different answers for the same question.
See, I am here, I have given a equation of a normal line, okay, where P, Q, and R represents a different terms. That is why this answer is changing. It is not like that I cannot prove the two answers. Okay, you proposed me different direction ratio. That is why there is a different equation. Otherwise, it will not happen like that. And here our point is 1, 1, and minus 1. The moreover fact to that is,
My point is the problem is
yes,
not in a proper manner,
how?
because you cannot have two different values for P plus Q plus R
Why?
or Q minus R.
Why? There is a parameter. I have told you in the equation while writing the equation, there is a parameter T belongs to R. That parameter will be managed accordingly. That is why there are two different answers. In fact, there can be some more answers also because parameter is varying. Okay, let me move to the next question. Find out the critical points of the function fxy equal to y square plus 4xy plus 3x square plus x cube. Find out the critical points for this function. Please try this. How we can find out the critical points? Anybody? What are the critical points? First of all, what are the critical points?
For the critical points, we have to put f equal 0 and f equal 0 for being both the equations and find the value of x and y.
So, is all the critical points are included with this manner, or there are some critical points will left also? Alekha ji. So as someone has told that in order to find the critical points, we need to find out fx at xy and put it equal to 0, and we need to check also fy at 0, 0. So after this also we can also consider some more points as a critical point for which this partial derivative fx, this partial derivative fy, any of them or maybe both of them does not exist. Okay, so to find out the critical points, we need to check where these partial derivatives are zero or any one of them is not defined or does not exist precisely, I can say. Okay, so find out what is the partial derivative of f with respect to x. It will come out to be 4y plus 6x plus 3x square, while with respect to y, it will be 2y plus 4x. Okay, now put these values equal to 0, fxy equal to 0. It will give us 4y plus 6x plus 3x square equal to 0. This is some equation number 1, you can say. And fy xy equal to 0. This will give us 2y plus 4x is equal to 0, which will give us y is equal to minus 2x. Suppose this is equation number 2. Now put this value of y in equation number 1. So we can say by 2 and 1, 4 times minus 2x plus 6x plus 3x square equal to 0. So this will give us 3x square minus 2x equal to 0. I hope I have done correctly. So this will give us 3x minus 2 equal to 0. This will give us x, it can be 3 or x can be 2 by 3. Now by equation number 2, we can write get y is equal to 0 or minus 4 by 3, corresponding to 0 and corresponding to 2 by 3. So we get the critical point as 0, 0, 2 by 3 minus 4 by 3 are the critical points of the given function f. Okay, does anybody has any doubt in this? Then please ask.
Sir.
Okay, so let me move to the next question number 6 for find best is examine the local extrema of the function fxy is equal to 6xy minus x squared minus y cubed. So examine the local extrema of this function. This is a function of two variables. Again, we have to find out critical point and we have to apply the second derivative test to see that what is the point, critical point corresponds to local maxima or local minima. So please try this. I'm just coming in 2 minutes. Any probable answer? You are not saying something, I guess, a little. Please tell me. What are the critical points?
Critical points are 0, 0 and 18, 6.
8 and 6.
18, 1, 8. 18,
Okay.
6.
Okay. And what are at these points? What these points correspond? I mean, local minima, maxima, or saddle point, something.
So saddle point at 0, 0
Okay.
and local maxima at 18, 6.
Okay. Let us do it. Partial derivative of x with respect to partial derivative by f with respect to x will be 6y minus 2x, and fy at xy will be 6x minus 3y square. So we will put these values equal to 0, and from the first we can get x is equal to 3y. I'm skipping one step. You can see it. And fy at xy equal to 0. I'm again writing 1 and 2 because it is a different question. So I can again count question numbers. So I hope you can manage that. So it will be 6x equal to 3y square. And by 1, we can put the value of x. It will be 18y equal to 3y square. So this will give us y into y minus 6 is equal to 0, which corresponds to y, 0, and 6. And corresponding to these values of y, we can get x is equal to 0 and 18 by question number 1. So we get the critical points 0, 0 and 18, comma 6 are critical points of f. Now we need to check what is this correspond, like local minima, local maxima. So for that, we need to compute the second order partial derivatives. So fx x at xy, this will give minus 2. Fxy at xy, this will give 6. Fyy at xy, this will give minus 6y. And now we need to put the value of these points. First of all, we need to check fx x fyy. y square. This will be equal to minus 2 minus 6y minus 6 square. It will give us 12y minus 36. Now we need to check what is the value of this expression. First of all, at 0, 0, it will give us minus 36, which is less than 0. Therefore, 0, 0 is a saddle point of f by second derivative test. Now, compute fxx, fyy minus fxy square at the point 18, 6. So this will give us 12 6 72, which will give us 36, which is greater than 0. Now we need to check the sign of double derivative of x at x. So 18 minus 6. Since it is minus 2 independent of any variable, so this is negative. So we can say by again the second derivative test that 18 or 18 comma 6 is or you can say corresponds to a local
Maximum.
maxima. Okay, so after this we can go to the next question, that is again an example of Euler theorem for homogeneous function. Let u is equal to x square plus y square sine inverse x square plus y square 2xy. Then find the value of x square uxx plus 2xy uxy plus y square uyy. We need to find out the value of this expression, and we can treat this as our first part. Then I will let you know in the second or third part I am changing function a little bit to get a better understanding. So please find out the value of this by Euler's theorem.
2u.
2u. Okay. Why?
So again, this is a homogeneous function
Of degree. Degree is
of degree
important.
2.
Okay.
So
Yeah.
by putting Euler's theorem, 2 into 2 minus 1 into u, so
Mhm.
that will be 2u.
Okay. What if it is a function of degree 3?
So then it will be 6u.
Okay. So first of all, let us see the degree of this function. We will put x as lambda x and y as lambda y. We will substitute this. We will get lambda x square, lambda y square into sine inverse lambda x square, lambda y square divided by 2 times of lambda x, lambda y, and this will give us lambda square x square plus y square sine inverse of again the same expression. This will be this. Now clearly one can see that this is xy. Therefore, uxy is a homogeneous function of degree 2. Now, since it is a homogeneous function of degree 2, we have recalled the Euler's theorem. Let me go again to that. So what Euler's theorem says? Euler's theorem says if we have a function of homogeneous function of degree n, then we can say that this expression has the value n into n minus 1 into f. So let us compute, or you can say get the value of this expression with the help of Euler's theorem. So by Euler's theorem, we can say that x square uxx plus 2xy uxy plus y square will have the value n into n minus 1 into f. So here the value of n is 2, so it will be 2 into 2 minus 1f, which will be equal to 2f. Okay. Or sorry, here we are, since we are here using u, so we will here only use u. This will be 2u. So as I have asked one person that what if it has a degree 3? So here we will put value 3 and we will get 6u as answer. So let me a little change the function like this. If we will take uxy as sine inverse x square y square 2x, then what, how the value of the same expression will change? Try it. How the value of the expression change? First of all, the question arises, does this function is a homogeneous function? Somebody?
No.
Okay. How? How
So by
can
putting lambda x and lambda y, we can see that
you?
we can't express it like that.
We can't get lambda as outside. Okay. So can we make it homogeneous? I understood it is not homogeneous, but can we make it homogeneous?
Sine equal to
Yeah, nice.
Yes, sir.
So we can make it homogeneous in the way we can write it as sine u and just, just a second, sine u equal to x square y square divided by 2x, and we will assume this function now as some hxy. Okay, now please check this function h is a homogeneous function or not.
No, sir, this is not a
It is not a homogeneous function. Why? See, put substitute lambda x and lambda y and check lambda x square lambda y square divided by 2 lambda x. It will give us lambda times x square plus y square divided by 2x. Okay, this will be lambda times of x. So what you want to see, Nikhil, now? Is it homogeneous or not? So it is a homogeneous function. Therefore, h is a homogeneous function of degree n. So the motive of this giving you this question is there is a possibility that a function may or may not be homogeneous, but after some substitution or after some, yes, please. Muthukumarji, you have raised your hand.
so by mistake.
Okay, okay. So I want to tell you here that after some substitution or computation, we can take consider some function which is a homogeneous function. Now we are aware about that this function is a homogeneous function. Okay. So by Euler's, we can apply Euler's theorem on this function. So what we will get by Euler's theorem? X square
0.
h x x. Okay, let me see. 2xy hxy plus y square hyy is equal to 1 times 1 minus 1 into h, which will be equal to 0. Okay, so can I move from this one equation to some terms of u? Can I move in this way? Since we know that this h is nothing but sine of u. So what will be the value of this? Hu will be Hu. What is the value of Hu?
Cos u.
Cos u. Or if I would talk about precisely what I have to find out, I have to find out Uxx. So first of all, what is Ux? Ux will be Hu or something else. Tell me.
Into ux.
Capital X.
Into Ux.
Hmm?
Is that so? Tell me. Okay. So we need to just put the value of this HSX, HXY, and HYY in this equation in terms of U. Then you will get what will be the value of this HXX and HYY. So I'm leaving this part to you. Now, in the third part, my motive is here is clear in the second part that I just want to make it clear that there are some functions which are not homogeneous, but it can be made homogeneous. While since we have learned about that how to apply Euler's theorem on a homogeneous function, what if the function is not homogeneous, or you can say it is an addition of homogeneous function with different degree? Then how we will apply the Euler's theorem? So for that, consider uxy is equal to x cube plus y cube sine inverse x square y square divided by 2x. So now tell me what here how we will apply the Euler's theorem.
So this is homogeneous.
It is homogeneous of degree
3.
3. How? Tell me.
Split,
So
split to two homogeneous functions f plus.
Exactly. Exactly. This is a addition of two homogeneous functions from Adit. Uh,
yes, sir.
yeah. So this is not an homogeneous function explicitly. This is an addition of two homogeneous functions. So you need to think about it again. Then how we will apply the sorry, how will you apply the theorem, Euler's theorem, in fact. So I hope everybody is clear with the second part. You can substitute hxx with some uxx or hxy with some uxy. If not, then you can ask also. Soumyadev, is it clear how to substitute h in terms of u? Soumyadev, anyone other? Yes?
hx
Yes,
hx
sir.
is hu into ux.
Yes, exactly. So we need to apply the chain rule over h. Since h is a function of xy and we know that h can be also written in terms of u, then we can write h as hx as some hu and ux. In the similar way, we can find out the higher order derivatives also. Okay, let me write it here also. Otherwise, it will make confusion for others also. I'm writing this part. You can do the third one. So hx is nothing but hu into ux. Similarly, hxx is nothing but hu, or you can write it in here. Hu is, what is h sin u? So it will give us cos u into ux. Now hxx will be equal to, we need to differentiate this function with respect to u minus sin u, and again ux square plus, what will be the other factor? We can directly differentiate cos u into some ux. So in this way, you can find out hxy and hyy, and you can substitute in terms of uxx or uyy, and you will get some value of the Euler's from the Euler's theorem, or you can say this equation number star. Okay. So anyone, what is the answer for this third part? Third part.
Take the first function as f, second function as g.
Yes, yes.
Apply Euler's theorem separately for f as well as for g
Okay,
and add the variables.
okay. So what will be the answer? Okay, let me do it here. Consider this function as some fxy, this function as some gxy. First of all, let me mention here, this is not an homogeneous function. By the definition, lambda x cube, lambda y cube, sine inverse, lambda x square, lambda y square divided by 2 times lambda x into lambda y. So this is a function, so it will give us lambda cube, x cube plus y cube, but the other factor will not give us any lambda outside. So we cannot say that this is some lambda to the power m of uxy for some m. Therefore, u is not a homogeneous function. But we can write this function as a sum of two functions that are homogeneous. Okay. We have wrote this function u as a function of sum of these two functions, and these two functions are homogeneous, and we will prove that first how these functions are homogeneous. F of lambda x lambda y, this will give us lambda x cube plus lambda y cube, which will give us lambda cube fxy. So this is a homogeneous function of degree 3. Now g of lambda x lambda y, this will give us sine inverse, again x square plus y square. I have skipped one step, you can check it out easily.
Is
G,
it not for any m?
what?
Any m or some m?
Some m, or you can say in fact any m. Here there does not exist any m, any m. So here this g function is a homogeneous function of degree 0. So by Euler's theorem, we will apply Euler's theorem on both the function explicitly. The first function will give us x square fxx, 2xy xy, fy y square fyy will be equal to 3 into 3 minus 1 into f, while the function g will give us gxx, 2xy, g of xy, y square, g of y. This will give us 0, 0 minus 1, g. So this will give us 6f. This will give us minus g. So at the end, we will get x square by adding this 1 and 2, add 1 and 2, which will give us fxx plus some gxx, 2xy fxy plus gxy, y square plus gyy is nothing but 6f minus g. Or you know that by the algebra of derivative, we can say that x square is nothing but this vector is nothing but uxx, and this vector is nothing but uxy, and the last vector will be uyy, which will give us 6 times of x cube plus y cube minus sine inverse x square plus y square divided by 2xy. I hope everybody is clear with this. So let us move to the next question, which is related to the relative minima. So in fact, find, or you can say examine, the relative extrema of the function fxy is equal to 4x square, and this is a nice function, and I am saying this function is nice because it is continuously differentiable, or you can say it is differentiable. So we can say that this is a nice function. So we need to find out the critical points first, then we need to see that what those critical points corresponds, and also we will find out related extrema value. Here we can also find the relative extremum value also. Please try it, find out critical points, and then this value.
Is there any difference between relative extremum and local extremum?
No, there is a different term only.
They are different.
You are saying different, or you are saying that
I am asking whether relative extremum
I
is
am
same as
saying
local
there are
extremum.
just they are just two different names. Meaning is same. That relative is same as local.
So your answer is they are same.
Yes.
Thank you.
Please try find out this critical point, and then this relative
Points in 1 by 4 and 0.
1 by 4 and 0. Okay.
Yes, sir. Same.
Okay. And what will be what that point corresponds? Local minima, maxima. Fx I will be 8x minus 2 and f2y.
Local minimum.
Sorry, can you repeat it? Put fx xy equal to 0 and to 0. So this will give us 8x minus 2 will be 0 and x will be 1 by 4 and y will be 2y will be 0. Therefore y will be 0. Thus 1 by 4 comma 0 is a critical point of the function f. Now in order to decide this is a relative minima or relative maxima, we need to compute the double derivative. So double derivative is 8.
Local minima, sir.
Okay, fxy will be 0, fyy at xy will be 2. So first of all, we need to compute the value fxx, fyy minus fxy whole square. This will give us 8 into 2 minus 0 square, which will be 16, and this is greater than 0 for any xy. So, but we need to compute at the critical point, therefore it will also give at critical point is equal to 16, which is greater than 0. Now that double derivative or double second order partial derivative with respect to x at 1 by 4 comma 0 also give us 8, which is greater than 0. Therefore by second derivative test, by the second derivative test, 1 by 4 comma 0 corresponds to the relative minima for f. Now, what is the value of relative minima? I think
3 by
that
4.
good. I thought you forgot it. So it will give us 4 into 0 square and 1 by 4 into 1 by 4 square plus 0 square minus 2 into 1 by 4 plus 1. 4 into 4 square plus 0 square minus 2 into 1 by 4 plus 1. So it will give us 1 by 4 minus 2 by 4, and it can be written as 4 by 4. 4 plus 1, 5 minus 2, 3 by 4. Okay. So next question, question number 9. If u is equal to x cube plus y cube and v is equal to xy plus yz, w is equal to z minus x minus y, then find the value of the quantity x, y, z and x, y, z divided by this u, v, w. Find out this value. Try it first, then we will discuss it. Yes, please. Another.
3 whole into s square y plus s square z minus 2y cube.
Okay. So first of all, let me know that which one is easy to compute first, the first one quantity or the second one quantity, and why. Anyone? Which one is easy to compute? The first quantity or the second quantity, and why? So let me tell. It is easy to compute this first quantity. And the reason is we have given u in terms of x and y, v in terms of x and y, and w in terms of x and y, z. So because we know that the Jacobian, it is nothing but the Jacobian of uv_w with respect to x, y, z. So it's nothing but ux, uy, uz. And the second row is vx, vy, vz, wx, wy, and wz. So we need to compute this partial derivative, and we have given u, v, and w in terms of x, y, and z. Therefore, it is easy to compute. Thus, first of all, let us compute what is the partial derivative of uxyz, or for simplicity, convenience, I can write directly ux. It will be 3x square plus 0. Again, the same reason that we are treating y as constant. Uy will be 3y square and uz will be 0, while Vx will be equal to partial derivative of this. I'm writing so that we don't need to look it again. So it will give us only y, while v with respect to y will give us x plus z, and v with respect to z will give us only y. I think I'm doing correct. Okay. So next one is
Yes, sir.
wx. So wx is z minus x minus y. The partial derivative of with respect to x, z minus x minus y. This will give us minus 1. Wy is also minus 1, and wz will be 1. So we need to put these values in that Jacobian to find out that value. This will be u, v, w, x, y, z. So this will give us 3x square, 3y square, and 0. And the other one is y, x plus z, y, minus 1, minus 1, minus 1. So first row will give us 3x square into minus x minus z plus y. Second row will give us minus y plus y. And third row is, since it is 0, so we don't need to write it. So this will also give us
Del W by del Z is 1.
del w by del z. Oh, I'm sorry. Thank you. We have written here 1, so but by mistake I have written it minus 1. So this will then again be something else. This will be y plus y. Okay. So this will give us, thank you. So 3x square y minus 3x cube minus 3x square z, and this will give us minus 6y cube.
Expansion is different.
Yes. Sorry.
3 into
Sorry, Muthukumar, can you repeat it?
3x squared into
Hmm.
X plus Y plus Z.
x plus
Sir,
z.
x plus y plus z, that should be x plus z plus y.
Oh, yeah. That because of this one here also will change. Yeah. But it will also come x plus z plus y. Right? You were saying this.
Yes, sir.
So, okay. Let me again write it. 3x cube, and it will give minus 6y cube as 3x square y, 3x square z. Thank you. Thanks a lot. So we have find out this value. Now the next task is to compute this. So what is the value of this? No,
Reciprocal
no,
of
no,
the
Swamit,
previous
you
one.
will not tell. You don't need to tell.
Sorry, sir. Sorry, sir.
Let the other also participate. So anyone else? What it can be and why? Alika?
No,
Alika?
1 over that result.
Sorry?
1 over that result what you have obtained in the first.
And what will be the reason by of this reciprocal? I mean, why we can say that?
The Jacobian del of UVW by del of
Yes, yes.
XY.
Okay. There's a properties of Jacobian that we if these are, you can say j, this is some j and this is some j dash, then j into j dash will be 1. Therefore, this will be nothing but 1 by j. J dash nothing but 1 by j, which is equal to 1 by 3x cube minus 6y cube plus 3x square y, 3x square z. Okay. So the next question is 10. Find out the absolute extremum value of fxy is equal to x square plus xy plus y square minus 6x plus 2 on the rectangular plate, that is this and this. Please try this.
Hello,
Hello,
hello.
hello, hello, hello.
You are waiting for us to answer, or
I'm waiting for you to try it. Then we can do here also.
as usual, you have to find the critical points.
Okay, but what are the critical points that I know what is the approach? That's why I'm waiting for the others. Yes, please.
So
Okay.
4 comma minus 2 is coming out to be.
Okay,
At the
so
critical points, find out the value of f,
yes,
and all the four boundaries will have to find the extreme value by taking one of the variables as constant.
okay.
Then we will
So
get
in
total.
this, only in this you are taking it as a constant, or it can be in other cases also. It is a generalized statement that you are
Yes,
saying.
statement because on the boundaries, by
Hmm.
taking x is equal to 0, you will get a f of y will come. It's a function of y. So using one dimensional case, you can find out what is the maximum minimum values,
Okay.
and then x is equal to 5 in all four.
Suppose rather than rectangular plate, I will give you some other curve like circle or something parabola. Then I'm asking for the others' perspective also that they will definitely understand it better way. Suppose in this, rather than this, we have given some curve 6x square. Oh,
You have to
then
find the values at the extreme points.
okay.
So I think
So
we will have to find the critical points, and then we have to check whether those critical points lie in the regions or not. Those
mhm,
which will lie, we will take them. If some
okay,
of them don't lie, then we will reject them.
okay. And what about the boundary part? I'm interested in that boundary part. How we will deal with that boundary part? As sir told us that we will like substitute or we will put some as constant. So can we say that we are putting some as constant, or we will put convert our two variable function into one variable by putting that function? For example, I'm giving you, I'm just writing, I'm not saying this will lie on something. So I'm giving you a y equal to 4 minus x and some x equal to 0 or y. So what you have to do here for the boundary, especially I'm telling you for the boundary. Here, this is x equal to 0, this corresponds to y equal to 0, and this is y equal to 4 minus. So we need to consider three cases. The first case corresponds to y equal to 0, the second case corresponds to x equal to 0, and the third case we will substitute y as 4 minus x, then we get our function as a function of one variable, and we will proceed with that. I hope everybody is convinced with this explanation. Okay. So let me come to this question, our actual question. So first of all, we will draw our this rectangular plate. This will be x equal to 5, or this is some y equal to minus. So I hope this is the reason. Okay. So we will write this line as L1, L2, L3, L for boundary case. First of all, we need to compute the partial derivative. So fx will give us 2x plus y minus 6, and fyxy will give us x plus 2y. So put fxxy equal to 0 and fyxy equal to 0. So it will give us that 2x plus y equal to 6, and it will give us x is equal to minus 2y. Now assume that this is some equation 1 and substitute this value in this. This will give us 2 into minus 2y plus y equal to 6. This will give us minus 3y equal to 6. This will give us y equal to minus 2. And by 1, we can say that x will be equal to plus 4. So I think someone also told that 4 comma minus 2 is a critical point. The critical point is correct. 4 comma 2 is a critical point of f. Now let us see, this is a relative minima or maxima. Does anyone did that?
Maxima, sir.
Maxima. Okay. So f x x x y
No, no,
will
no.
give
Sorry, sir. Sorry, sir. This is a minima, minima.
minimum. Okay.
Sorry, sir.
It's okay. F x y x y. This will give us 1. F y y and x y. This will give us what? 2. Okay. So f x x f y y minus f x y square. This will give us 4 minus 1, that is 3. And this is for general xy. And at our critical point, what is our critical point? 4 comma minus 2. This will again 3, which is positive, and fxx at 4 comma minus 2 is nothing but 2, which is greater than 0. Therefore, from the second derivative test, we can say that 4 comma minus 2 is, or you can say, corresponds to a local minima for f. Okay. Now, the left part is what about the boundary? So there are four boundaries L1, L2, L3, L. If I would write explicitly the equation of each of them, so what will be the equation of L1? Anyone? What will be the equation of L1?
Y equal to minus 3.
Y equal to
Y equal to
minus 3.
minus 3. Okay. And what is the equation of L2?
X
X
equal to
equal to 5.
5.
X is equal to 5. Good. And what will be the equation of L4?
X equal to 0.
X equal to 0.
And L3, Y equal to 0. Okay. So we are well aware about the equation and we need to see whether the function on this boundary correspond to some critical point or some relative maxima or minima. So to calculate that, first case is L1. So as someone told that L1 is y equal to minus 3. So we will put y equal to minus 3 in our given function. So it will come out to be x square plus x times minus 3 plus minus 3 whole square minus 6x plus 2. So this will give us x square, sorry, x square
Minus
minus
9x.
9x plus 11, right?
Yes.
So now it is a function of single variable now. Suppose some function gx. Now you need to apply the theory of single variable, that is g dash x will be 2x minus 9. Put g dash x equal to 0. This will give you x equal to 9 by 2 is the critical point of the function g. Okay. Now g double dash x is 2. That implies g double dash at 9 by 2 is nothing but 2 which is greater than 0. Now tell me
What is
what
the
will
need? What is the need to find G double dash?
how will you decide that this is a I'm showing that this is a relative minima or maxima? That
Why?
is the
What is the need for that?
see I get your point that there is no need, but I'm just telling about recalling the single variable theory. I need to do that also for the recalling. From here we can decide the critical point of function f. Okay, so we can see that by a second derivative test that x equal to 9 by 2 corresponds to a local minima of g. Okay, this is for just practice, but we are interested in the critical point. So what was the critical point? 9 by 2 comma minus 3 is a critical point of f. Now the other line is L2, and L2 I think corresponds to x equal to 5. So we will put this value 5 comma y. This will give us 5 square plus 5y plus y square minus 30 plus 2. So this will give us y square plus 5y, 25 plus 2, 27 minus 3. So this will again a function gy. Now differentiate this with respect to y. So this will give us 2y plus 5. And we will put, for simplicity, let me write, sorry, some gy. So put g dash y equal to 0. This will give you y equal to minus 5 by 2. Therefore, what will be the critical point? Critical point will be 5 comma minus 5 by 2 is a critical point of function f. Okay. Now similarly, we need to see L3. L3 is correspond to y equal to 0. So fx comma 0, this will give us x square plus 0 plus 0 minus 6 x plus 2. So this will some hx suppose. So h dash x will be 2x minus 6 x square minus 6x plus 2. Therefore, now put h dash x equal to 0. This will imply x equal to 3. Therefore, 3 comma 0 is a critical point of h. Now the last line is L4 and that corresponds to x equal to 0. So again f0y will be come out to be 0 plus 0 plus y square minus 0 plus 2. So this is some again some function, suppose some h1.
3 comma 0 is a critical point of H or F.
Oh, typo, f.
Can we write so? 3 comma 0 is a critical point of F.
um yes, we need to judge over it, like we need to think about the values of here. I am writing critical here in the sense of that we need to check the value for the absolute minima or absolute maximum. So that is why I'm writing here. So here this will be y square plus 2. So h1 derivative of y will be some 2y, which now put h1 derivative of y equal to 0. This will give us y equal to 0. Therefore, 0, 0 is a critical point for f. Okay. Now we got some points besides. So which points we need to check here and what is the functional value over these points. So first of all, what is our point? 4 comma minus 2. First of all, 4 comma minus 2, and the second point is 9 by 2 comma minus 3, 9 by 2 comma minus 3, and the third point is 5 comma minus 5 by 2, and the fourth point is 3 comma 0, and the other point is 0 comma 0. Okay, now see here that rather we haven't missed any point, like I'm talking about these points. We need to include these extreme points also. What they corresponds to, this corresponds to 0, 0, and we have included 0, 0. This corresponds to some point 0 comma, sorry, 5 comma 0, and this corresponds to 5 comma minus 3, and this corresponds to 0 comma minus 3. So we need to see 5 comma 0, 5 comma minus 3, and 0 comma minus 3. We need to include these points also. So the other points are 5 comma 0, 0 comma minus 3, and 5 comma minus 3. So we need to compute the value of f at these points. Then we need to check whichever point corresponds to the maximum functional value. That point will behave as absolute maxima, and whichever point corresponds to the minimum value, then that point will be considered as absolute minima. So I hope you can find out these values. Then we can decide which is the absolute maximum value of f and what is the absolute minimum value of f, and with which respect to which point we are deciding.
Is it necessary to consider the corner points?
Yes, it has also been told in the lecture also that we need to consider the corner points. Anyone else? Anyone else? I am again repeating that here I am telling this as critical point in the sense it is a critical point of our single variable function, and we are checking the values on these points. We can also call it some boundary point also. So it's just in the sense that sense I am saying critical. So don't create that confusion in that scenario that critical point means that partial derivative of fxy is 0 or something else. So now you need to compute these functional values, and then you can easily decide what is the absolute maxima and absolute minima. If anybody has any doubt, then you can ask. Otherwise, we will complete this session. In the last lecture, someone has asked about that peak one lecture that sine inverse expression, sine of tan inverse y. So I think that student is not here. So we will uh, discuss it when he will also join the meeting, maybe in the next meeting. So if everybody is fine, let's end the session.
Thank you.
Okay, let's stop the meeting. Everybody can leave. Thank you.
Sir, I have a question. Can
Yes.
you